Okay, thank you very much. Welcome for our lesson, Mr. Omar. To start with, I am introducing a new topic since we covered the last topic, food and nutrition. So I am introducing a new one. Now, the topic is energy. And I know that this is not your first time to hear about energy because in your previous classes you have dealt with some of the topics that are related to this. So I will advise you to go back in the previous classes and read about the subtopics and topics that are related to energy that we are covering, because at the end of this topic I will have general question from your previous classes to standard 8 about the topic energy. Now, what you have to look about in the previous classes, I say we have to go back and look about light energy. You covered in your standard 6. You have sound energy in your lower classes. We have heat energy and also electricity that you covered in standard 7. Those are some of the related subtopics in your previous classes, and specifically talk about the levers in standard 7. You covered levers where we said that levers are machines that make work easier by increasing the effort distance. Now, you have to understand that there are 3 classes of levers, of which we have the first class lever, we have the second class lever, and also we have the third class levers. Now, how can you categorize? How can you know that this machine is in the first class, this machine is in the second, and this machine is in the third class? In standard 7, we said that they have 3 main parts, which is the effort, the fulcrum, and also the load. Now, the position of these 3 points, I will now show you that this is a machine in the first class, in the second class, and also in the third class. Now, what are some examples of machines in the first class? In the first class, we said that the fulcrum is in between the effort and the load. So when you come across a machine that is having the fulcrum or the pivot in between the effort and the load, now that machine will be categorized as the first class levers. Now, what are some of the examples of machines in the first class levers? We have the crowbar, is a machine in the first class lever. We have the glow hammer, we have the seesaw, we have the pair of scissors, we have the nail cutter, and we have the lid opener. Those are some of the machines that are having their fulcrum in between the effort and the load. Now, the second class levers, we find that the machines under second class levers, the load is in between the fulcrum and the effort. The load is found in between the fulcrum and the levers. Now, any machine that is having the load in between the fulcrum and the levers, the machine will be categorized as the second class lever. Now, some of the machines under the second class levers, we have the wheelbarrow, we have the bottle opener, we have the nut cracker, we have the human foot, we have the door hinges. When you are opening and closing the door, you will find that the load is the door, where you are holding your hand is the effort, and the hinges are the fulcrum. Now, those are some of the examples of machine under the second class lever. Now, lastly, we have the machine under the third class lever. We find that under this category, the effort is in between the fulcrum and the load. Now, examples of machine under the third class levers, we have the spade, we have the fishing rod, we have the human arm, we have the tongs, the djembe, the sweeping broom, and the tweezers. Those are the machines under the category of the third class levers. Now, I have narrowed it down to levers because I know it was the last topic you covered before you joined the candidate class. Now, In our candidate class, under the topic energy, what are we going to cover? We are going to cover, first of all, we have to discuss the meaning of the word energy. What is the meaning of energy? Number two, we have to talk about types of energy. Number three, we will talk about transformation of energy from one level to another. Then lastly, we will talk about methods of conserving energy. Those are now the subtopics that we are going to cover with you under energy in candidate class. Now, to start with, I said we will start by the meaning of energy. If you are asked what is the meaning of energy, what will you say? The meaning of energy, I have highlighted here, that is the ability to do work. Energy is the ability to do work. For any work to be done, energy must have been applied there. For any work to be done, energy must be applied there. So that is the definition of the term energy. If asked, you will have to define like that. Now, what are other examples of energy in use? We want to look about some of the examples of energy in use. What are some of the duties that have to be supplied with energy to be done? Now, there are very many examples of energy in use. Number one, this one, I mean that they cannot happen without energy. So we want to look about at what are the sources of energy and how are they operating with this energy. Now, number one, we say that a person gets energy to work from the food eaten. So people and animals cannot wake up and walk to any other places without food. You find that somebody who is hungry cannot operate any job because there is no energy. So that person has to eat food. You will find that after consuming certain food, you are sweating, then you have energy. You can work anywhere with that energy because you have consumed food. So food has supplied energy to your body for you to work. Without food, you will not have energy. So that is the first example of energy in use. Number two, we find that vessels like vehicle, motorbikes, tuku cannot move without fuel. What is fuel? Now, fuel is the one that is supplying energy to vehicle, to motorbikes, to tuku. And types of fuel that is supplying energy, we have petrol, we have diesel. These are some of the examples of fuel that supply energy to these vessels to move. Number three, another example of energy in use is a television. I know that many people have televisions. A television cannot work without electricity or car battery. Without car battery or electricity, you find, or solar energy, you find that the television cannot convey messages, cannot play music, cannot entertain people with drama and etc. So you find that the television is getting that energy from electricity. If not electricity, you can supply energy from the car battery or solar energy. Solar energy means sun. We have the solar panel that connects solar energy to electricity. So we'll have to talk about that energy transformation when we reach that level. That is another source of energy in use. Number four, we also have what we call the radio. What is a radio? This is a machine that conveys message. So for messages or music to be played in a radio, you must have connected dry cells to that radio or car battery to work. If the car battery has run out, you find that it cannot work. So you have to provide new dry cells for the radio to work. That is another example of energy at work. Now, we have a torch bulb. A torch bulb is a device that provides light in the house. At night you find that you cannot read, you cannot do your course without light. So you find that if you provide new dry cells to the torch bulb, it produces bright light. But if the dry cells are exhausted, you find that the light produced by the bulb is dim. And if you continue using them, you find that it completely goes off. So what do? You have to supply with new dry cells that can provide energy to the torch bulb to function. Number 6, we have athletes, especially those athletes who run long distances. You find that when you go to Home of Champions in Eldoret, you find that people, especially the Kalenjins, run long distance. You will find that these people are using food that provide a lot of energy to their body for them to run. You find that somebody is running 8 kilometers, 15 kilometers. You have them in your you have heard them being mentioned. They are bringing gold medals because they are consuming food that is having a lot of energy for them to run such a kilometers. That is also another source of energy. We say for people who are running long distances have to use food that is providing a lot of energy. Number 7, we have windmills use wind energy to pump water. Windmills are machines that pump water. For them to rotate and provide energy, there must be wind. So wind is the one that is providing that energy for the windmill to rotate. As it rotates, you find that it can pump water to far distances, supply water to different houses in our domestic use. Lastly, in Standard 7, we discuss about on how hydroelectricity is produced. Hydro, the word hydro means water. Now, you find that water dams like Masinga, Kindaruma, and Kiambere, which is found along River Tana, is having enough energy to turn the huge generators to produce electricity. That is hydro. The electricity that is used here in Garissa, you find that its source is along the dams that are in River Tana here. We have mentioned some of them. Masinga, Kindaruma, and Kiambere are dams that are providing energy to run the generators that are producing electricity. Now, those are some of the examples of energy in use. They are 8 of them, and we have discussed about them. We have said that all these vessels cannot work without the supply of that energy. Now, I'm moving to the second subtopic after looking on some examples of machines that cannot work without provision of energy. Now I am moving to the types of energy. We have kinds of energy. 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 Mainly we have 2 kinds of energy. The first one, energy stored in rest objects. We have energy in stored object. Energy in stored objects, which is known as potential energy. Potential energy. Energy found in stored objects is known as potential energy. Number 2, we have energy in moving objects. Energy in moving objects, or energy in motion. Energy in moving objects. This one we will term it as kinetic energy. Kinetic energy. Now, we say there are 2 kinds of energy, and we have energy which is in stored objects. I said this energy which is found in stored objects, we will term it as potential energy. And the second form of energy is energy which is found in moving objects. So the energy in motion, we have termed it as kinetic energy. Now, those are two forms of energy: potential energy and kinetic energy. Energy in moving objects and energy in stored or rest objects. Now, what are some of the examples of energy in stored objects, and what are some examples of energy in moving objects? Examples, when we talk of energy in stored objects and energy in moving objects, what are some of these examples that can show you that here we have energy in motion objects and here we have energy in stored objects? Examples: energy in stored objects, examples of energy in stored objects. Energy, number one, energy in dry cells. Energy in dry cells and car batteries. Number two, energy in food. Energy in food. And number three, we have energy in firewood. Energy in firewood. Energy in firewood. These are three examples of energy in a stored object. You find that before you connect the dry cell, it will just have the energy stored there for even 2 years. It will just be there before you connect it. So it is addressed. Energy in food, you can have food there, but before you consume them, you cannot get that energy. So you can store food. The food is just staying there, but it is having energy inside it. So before you consume it, that energy is not in use. So you have to consume the food first so that the energy can be produced. Three, we have firewood. Firewood also can be stored there before you lit their fire. It can be stored there for so many years. So there is just energy, but if you have not used it, there is no energy in use there. But now, let us see now examples of energy in moving objects. Examples of energy in moving objects. Good. Examples of energy in moving objects. We have running water, number one. Running water. We have wind. We have wind, and we have footballer. I will have to explain. We have footballers. Footballers. Now, how do we say that these are examples of energy in motion? You find that when water is running, for example, in production of hydroelectric energy, you find that water in dams is in motion. For it to move the turbines to rotate, that water is already moving. So the energy that is in moving water is the one that is causing the turbines to rotate, and hence production of hydroelectric power. That is, we are getting the electricity from moving water. Water is not stagnant. That water must be in motion, and that is why the turbines are moved very fast by the water, by the current of water. Number two, we have the windmills. The windmills are used to transport water from one place to another. So the wind is moving also. The wind is in motion, that is air in motion. So as the wind moves, you find that it also rotates the turbines, the windmills. As the windmill rotates, you find that it is providing a lot of energy to carry water from one place to another. And then lastly, the footballer food. For the footballers, if you have a penalty there and there is a goalkeeper, you find that the moving leg of a footballer is very fast. If the footballer foot moves very faster, now the ball will also move faster in connection of the speed of the footballer foot. But if it moves slowly, then you find that it will not be a high shoot. So you find that those are some examples of energy in motion, and that one is energy in stored objects. Those are just examples of stored and energy in motion. Now you can read ahead of me, so that tomorrow when I come to continue, you already have some knowledge, and also you go back to your standard 7 and your previous classes to discuss to cover whatever you had already covered concerning energy as we proceed with the topic. That is the end of our topic today. Thank you very much.